Assalamu alaikum. Okay, guys, so Shah Fahad Khan is back on your screen. Alright, guys, so now we are gonna revise the remaining inorganic chemistry that we have. Okay, we were done with physical chemistry in our previous videos, I mean. Alright, now the next chapters that I plan on doing include Group 2, Group 17 and period 3, along with another chapter, nitrogen and sulfur, and some bits of equilibria as well, in order to cover the AS Edexcel chemistry. Okay, so let's get started. Alright, guys, so group 2 of the periodic table. First of all, some of the students at this level might also still not know the difference between a group and a period in a periodic table. So group is the vertical column in the periodic table, up to down, okay, and a period is a horizontal row in the periodic table. Now the vertical column, there are 8 vertical columns excluding the transition metals. Transition metals include all those elements which are found in between group 2 and group 3. Now group 2 elements include beryllium, magnesium, calcium, strontium and barium. Beryllium is an exception, and that's not just beryllium, but the very first element of every group is always an exception whenever the chemical and physical properties are concerned. And the reason for that is because of a relation called diagonal relation, meaning the first element of the entire group will have properties similar to the next group. So for instance, if we talk about lithium in group 1, lithium would have chemical properties and reactions and all equations and everything similar to group 2, although lithium belongs to group 1. Similar is the case with group 2 beryllium, although it belongs to group 2, but it has properties similar to group 3, similar to aluminium. Okay, there are multiple reactions of group 2 that we need to familiarize ourselves with. Okay, and certain additional reactions, just to be on the safe side, will also be provided to you in this lecture. The first one is you need to know all the chemical formulas, ionic formulas of group 2 salts. Okay, and I know some of you might be thinking this is too basic for us. I always start from the basic. I start from the scratch and go all the way to the advanced. So please bear with me for just a few moments. Now, as you were speaking of group 2, we have group 2 nitrates, meaning beryllium, just exclude beryllium. We won't talk about beryllium because we're talking mainly about group 2 properties in general. So after beryllium comes magnesium. So we have magnesium nitrate, MgNO3 brackets twice. Okay, always remember that group 2 metals have a fixed charge of +2, and that fixed charge never changes. Okay, group 2 are one of the few cases in which you have fixed charge on their outer shell. So they have only 2 outer shell electrons, right? So the ions that they form, they are positive ion forming, right? They form cations, and all metals in general form cations. They tend to lose electrons. So as the group 2 metals lose their electrons, they form 2 positive ions: magnesium 2 positive, calcium 2 positive, strontium 2 positive, and barium 2 positive. Now, once you know this fact, you should also know the trend in their reactivity with water. How do they react as you add them to water, and how does the reactivity vary as we go down the group? So going down the group, and this is actually an exam question, as to describe and explain the changes in reactivity as we go down the group. So what do you guys think? How would we describe as well as explain the trend of reactivity going down the group? Well, going down the group, what's happening? Atomic radius is increasing. Nuclear charge is increasing, but the atomic radius is a much more significant factor. So that's the first point. Atomic radius increases. Number two, shielding effect also increases. So because shielding effect increases, the nuclear attraction experienced by the outer shell electron becomes weaker and weaker, right? And if the nuclear attraction experienced by the outer shell electron becomes weaker, then that would mean that it's more easier to lose electrons as we go down the group. So if it's easier to lose electrons, the reactivity increases as we go down the group for the general group 2 metals. Okay, they are all metals, so the major intermolecular force, the major force responsible for their physical properties, for example melting point and boiling point, the major force that needs to be broken down in order to melt or boil them is metallic bonding. Okay, so all metals in general have metallic bonds, so therefore group 2 metals also have metallic bonds in them. If you need to melt them, you need to break the metallic bonds. In certain situations, they ask you to compare the metallic bonds of group 2 metals with an ionic compound. They compare and contrast. So you should know that in an ionic compound, the melting point or the melting occurs once the ionic bonds are broken down. Whereas in metals, melting occurs once the metallic bonds are broken down. Okay? They are good thermal and electrical conductors because they have a sea of delocalized electrons. There might be a question on metallic bonding itself. Describe what metallic bonding is. The definition, basic definition, is very simple, but certain students tend to get it wrong because they do know the definition, but they don't know how to write it down on the exam. So the metallic bonding is actually electrostatic force of attraction between positive metal ions and a sea of delocalized electrons. Okay, once that is done, properties are almost done, and they are malleable, ductile, sonorous, all of that stuff for all metals in general. Next, we need to do reactions with water. Starting from magnesium. As magnesium is added to water, it forms magnesium hydroxide along with hydrogen gas. This is a very slow reaction. Okay, therefore we draw it by using a reversible arrow, and it's cold water that we are talking about. Okay, first let's do the reactions with cold water. So for magnesium, cold water means the water at room temperature, not the freezing water. Okay, in chemistry, cold water is referring to the water at room temperature. So as it reacts with water at room temperature, you get magnesium hydroxide along with hydrogen gas. Now in this reaction, you are often asked to describe the observation of the reaction. Describe what you would observe in this particular reaction. What do you think you'll observe? As you add magnesium to it, into water, first of all it would melt, it would dissolve, but this is going to be a very slow reaction occurring, and magnesium hydroxide forms. Magnesium hydroxide itself is a partially soluble solid. So a whitish solid that is partially soluble, it forms. So the second observation is going to be a cloudy solution forms. Okay, this is an exam question as well, that a cloudy solution forms. Then the third observation can be hydrogen gas itself. You are never going to mention the term hydrogen gas whenever describing the observation. Whenever describing the observation, you always mention that bubbles of a colorless gas slowly evolve, because it's going to be a very slow process. And if you want, you can also write it to be on the safe side, that it pops with a lighted splint, just to describe the observation of hydrogen gas itself. Okay, this was a reaction with cold water, and of course you also need to know how to balance this equation. Mg plus H2O, reversible arrow, MgOH brackets twice along with H2, and then balance it out. Okay, once that is done, Next reaction of magnesium is with steam, not with room temperature water anymore, it's with steam. Magnesium can react with steam, with water, H2O, but that's steam, to form a white solid known as MgO, magnesium oxide this time, along with hydrogen gas as well. So observations for this reaction would be a faster reaction, much faster reaction, because it's steam now that we're talking about. Steam has a much higher energy. Bubbles of a colorless gas, white solid formed, and colorless gas pops with a lighted splint. Always remember, you use the term lighted and not the term glowing, okay? Because it's a lighted splint that we use, not the glowing splint that we use. Alright, once that is done with steam, we are done with magnesium's reaction with water, okay, both steam and cold water. After that, let's talk about calcium. When calcium is added to water, now you know that the reactivity increases as we go down the group, so calcium rapidly reacts, or at least has a faster reaction compared to magnesium. Okay, it doesn't rapidly react, you can't say it's rapidly, but it reacts with water to produce a rapid stream of bubbles, you can say that. Okay, as soon as calcium is added to water, and bubbles of colorless gas are seen. Again, a partially cloudy solution is formed because calcium hydroxide is also not very soluble in water. By the way, magnesium hydroxide's pH is usually asked. Now you know that these are hydroxides, so they are bases, right? It's a base, that's not an acid. So exact opposite of an acid. And because it is partially soluble, magnesium hydroxide, the previous one, so it will be considered a weak base because it partially dissociates in aqueous solution. It's partially soluble. So the pH of that weak base would be considered approximately 10. Okay? This has been an exam question in which you are asked to describe or to guess the pH. Suggest type questions usually ask you the pH. So the pH, obviously, because it's a weak base, it's not going to be 14. It's going to be slightly lesser than 14, approximately 10. That's fine. What about calcium hydroxide? Similar pH, 11. It's fine. Okay, it's also going to be a weak base because not very soluble in water. Yeah. Once done with calcium hydroxide, next is, and yeah, the observation. So calcium sinks to the bottom, by the way. As calcium reacts with water, it sinks to the bottom, and calcium has a faster reaction. It produces a steady stream of bubbles, produces a cloudy solution. Okay, so these are the observations for calcium. After calcium reaction with water, magnesium, calcium, now we have strontium. So strontium is a much faster reaction. It quickly dissolves and reacts, and as it forms strontium hydroxide along with hydrogen gas, it also rapidly forms bubbles. The strontium hydroxide that it forms is actually completely soluble in water. So because it is completely soluble in water, it's actually gonna form a strong alkali. Okay, the pH is usually asked. The pH is 13 to 14 for strontium hydroxide, and bubbles of a colorless gas are also released in the same manner, and those bubbles also pop with a lighted splint. Okay. And then finally barium, similar reaction. Barium also quickly reacts, fastest reaction in fact. Barium hydroxide, which is completely soluble in water, very strong alkali, pH 13 to 14. Okay, so bubbles of a colorless gas are rapidly formed, and they pop with a lighted splint, and clear solution is formed. It melts and dissolves quickly. Okay, because transparent clear solutions are formed for both strontium as well as barium reactions with water. So I guess that's it for this video. We'll continue with the remaining reactions in the next video. Thank you.